live, I believe. Hello. Oh, I forgot something. Oh, base, yeah, the best maker in the village. I'm not sure about that though, because I don't know everyone. There is one engineer in this village who did some patents in the past, and he did some quite cool stuff. So I'm not sure about if I'm the best maker in the village, but I'm a quite above average maker in the street here. So from my neighbors, I'm probably top 3. Good evening, ladies and gentlemen and fairies. Or dudes and dudesks. Hello. Hello, Jody. Hello, Johnny. Hello, Jacko or Jacko. Yeah. Hello, Dutch. Hello, Yumbo. Hey, Kasper. Adam. Hello. Hey, Basil. Hey, Sonic. Hey, TMK. Good. Second best engineer. Yes. Hey, Peter. Greetings to Boulder. You have even a mountain emoji. Hey, Nishai. Hey, okay, Stilla. How are you? I need a booster today. I'm really exhausted. It's not sponsored. And this is sugar-free. I don't know where I get the energy from today. Colorado, Pete, yeah. What's Pete? What is your weather right now? What's the? But we only understand Celsius. Hey, Hannes. Currently, we have quite cold weather here in Central Europe. I don't know why. Hey, I'm a boy. Yeah, Sonic. Same here. 20, maybe 20. Yeah, it was quite cold. My batteries didn't even recharge. Hey, Hannes. It's last time. Yeah. Oh, what? Yeah, Kaspar, that was you just got the weather today that we had yesterday or the day before. I think on Monday it was like 14 degrees C. What? Hey, Lucas. Welcome to the chat. Pulling it from the ether. What are we pulling? Ooh, what are you? Yeah. Sunny. Oh, nice, jolly. As you're on the sunny side of the life. Oh, what? 38 degrees C. Well, that's madness. Oh, wow. Yeah, when on last weekend, like last week was like quite hot, yeah. I got like 100. Oh, yeah, 100 is like 37, 36 degrees C, something like that. Oh, congratulations to your graduation. All right, peeps, how do you enjoy the video that finally came out about this thing here? You know what? This actually works. We can plug it in and see that it works. It is slow. The communication is slow. We can probably optimize it somehow still, but it still works. Yeah. That I was happy. It was my birthday on Sunday. So that was actually a good birthday present that the video performed so well. I got like within one day it was 200,000 views, over 200,000 views or something. Happy birthday! Yeah, thank you very much. So I turned 46. If anyone asks, that's old. I don't. Serial, yes, USB, and this is right. Let's jump right in. Where's the Kicad? Your mother is 50. Oh, I could be your father then. Oh boy. Oh shit. Ah, Kicad window. Ah, the Kicad window is now covering my whole desktop. Ah. Ah. Ooh. Ah, here we go. What? Oh, your mother is then a cougar. She was 4 years older than your father. Nice. Yeah. I could be your father then. That's basically the reason why I mean, I'm not sleeping a lot currently, so I don't look as fresh as I could look. I probably am dehydrated, and my eye was damaged badly a few weeks ago. You saw it probably. Yeah, so I don't have kids. That's why I still look reasonably well. Yeah, it's wet. I just got a shower because I did some garden work today. I have a friend who is visiting me right now, and we did a lot of work in the garden, like carrying the dirt up. Yeah, PCB. Oh wait, yeah. Let's jump in. That would be what? This is not the project object recent M.2. Where is it? Ah, here, USB M.2. This is one PCB that we could do, but we can also do another one. Oh, look at that! The PDFs are showing here. So I have some of all the data sheets I put in my folder, but I can't probably upload them because of copyright. I can't upload them on GitHub, so I need like to do another repo for that. Where is it? Also footprints and stuff like that. The project so there are two projects. One that needs like the window is huge. Kicad can't handle my Windows setup. Okay, here. Way better. We switch to PCI Express USB bridge, and this USB bridge actually supports like high speed or whatever. But what we can do, we are using. Did I do it right? Wait, flash, power. Oh yeah, this part. Yeah, I want to maybe manufacture that. Using USB has the benefit that you can put like a device name and a manufacturer that shows up when you connect to the serial, at least in the browser. And then also USB, like full speed USB is like 240 megabits per second, which is way faster that I think we can handle anyways. I'm so thirsty. Yeah, so there are like two USB, or you can high speed USB or something. 480 or even faster then. All right. So it's 240 double bits. That would be a basis for some projects. I maybe talked about that before. Let's Let's see the. So I think this is figured out. I can't remember. We started this project ages ago, or I did at least. The only thing that we need to do, it's bits, not bytes. That would be fast. Yeah. So we already did the PCI Express stuff here. More RISC cores. What is this? Ground. Oh yeah, that's the ground plane. Oh no, but this is. Yeah, this will be alright. There is a huge inductor because we have like one of the issues with the old board. It got quite hot because we needed to step. I had an LDO that reduced the 3.3 volts to 1.8, but the consumption was like 170 milliamps. So we got like, it got really hot and the whole board was getting heat up, and we also wasted a lot of power this way. So this time I got a DC to DC converter. I think it was like even suggested by on the reference design for the USB thing. Oh yeah, this footprint. I probably want to make it smaller, but this chip also can get really hot because if you use it like in high speed, it can draw, I don't know, 600 milliamps or something. This is like red hot then. This is my footprint that I'm using for the MCU, which is good enough. I never had problems with ground bed like that. Hello, Dusty. There is one funny thing. Oh yeah, there's a lot that we can. So small. Small. Yeah, we have some stuff that we need to place there around. I'm not sure about this. I think this was the flash. And I think all the parts were available at LCSC, so we can just order it from JLC and it will be assembled and delivered. I don't care about anything anymore. That's what she said. And the idea was to put everything on the bottom of the board. So we looked, I think even Basil, Johnny, thank you for subs. We even checked to get like the right inductor that is like this millimeter high, because you have only like 1 millimeter, 1.2 millimeters of something in the specs on the bottom side. Hey Dutch. Basically we can put this everything on the bottom, and on the top we can just put a breadboard. How about that? That will be cool. And then you can put your own you can put your own project there. What? Where's Christian? What's happened to Christian? So bitluni, today you will teach me how to make PCB, right? Because I have no idea, by the way. What? I don't do the PCB. I just push around the parts here, connect them with the wires here. Oh, you can see the tool. Wait, move it over here. This is Kicad. You can also use like, I don't know, what is the JAC thingy, Easy EDA, which is also quite handy. And you just What? Hey Christian! Yeah, Easy EDA is cool. Especially if you BGA repolling, no, Rohan. I can't do that. I used BGA parts before, And basically what happens if the silk screen isn't good enough, you get shorts underneath the chip and you can't do anything about that. So I had so many problems with that in the past. I just love QFN package because that doesn't have lags that can cause like bridges easily. And you can still solder it with your hot air gun and soldering iron. PCB, we won't accept your PCB project. What do they say? What is the problem with that? Yeah, Autodesk has their own stuff. I don't know how it's called again. Oh, I use 0603 because I think, or is it 042? I think 0603 because I want to be able to. Oh, Fusion. All right. Oh, really? Oh, yeah, DRC. You before you send it off, you need to press this button and do whatever it says, because they will find okay, you can if you run DRC, you will get it will check for all the problems, and also you might need to. DRC stopped working. I don't know what's happening right now. Here we go. 144 errors. Okay. So it is actually, it added. Look at that. Yeah. Okay. It complains. I think these are the warnings. We can disable the warnings. And yeah, you need to. Oh yeah, we have something like that. This is for Isla. I can remove this because I don't know if I would send this to Isla. Probably not, because these parts I don't want to source all the parts. Yeah, everything you need like to for your board setup. No, not board setup. What is this? Constraints. Here we go. You need to enter more or less like the distance between the traces or whatever, the minimum things here. Yes, I'm back on Hackaday. I was already forwarded to that. Okay. Yeah, nice. Kicad default. Yeah, you can do right. Do. I think even I would always like. I would start with wider traces, like 0.2 at least, maybe 0.25 trace width. So you're on the safe side, and also clearance of 0.2 millimeters at least. Yeah, something like that. Anyways, this would be one thing that we can do, but we can do a simpler project. Okay, I don't want to spoil everything, but you remember this thing? Let me turn on the camera. Hot plate. Option 42. Wait, where is it? There is a GoFundMe still. Oh yeah, I did some excavations with my muscles today. That was terrible, I tell you. Wait, let me turn on the camera. Does it work? Yes, it works. You can see my mess. Why is it out of focus? Focus you. Oh wait, it's in photo mode. Let me put it in camera mode. Here we go. Yeah. Oh, the light is so hard. I need to move over this light somewhere else. I have moved it before for the shoot of the B-roll for my video, but now it needs to go again. All right. Yeah. And this is not bright enough if I want to record anything. Here we go. All right, so this is, by the way, this is my pop filter for the microphone. It's a fake tattoo sleeve. Yeah, I'm a bad boy. Here we go. Look at the. This is my debugging wire. Wait. Hocus focus. Here we go. Do you see the debugging wire? It's like a hair. Yeah. Cool. Yeah. If it works, it works. If it doesn't, this is this cute. Okay, here. You remember that? We took it already apart. So I want a PCB. Wait. I need to rewind. How do I rewind? Oh yeah, here we go. We rewind. So what I need, wait, is it the right direction? What do I do? Uh-oh. Yeah. Let's stop. Ah! Okay. Stop and play. Wait, rewind and play. Nothing. Didn't work, huh? What? Didn't I record? All right. Okay. So this cute device, I want to interface. I want a USB device. Okay, stop it. It's a little bit janky. It's falling apart. I don't want to destroy it completely. We took it apart, and the problem with taking it apart is that it stopped working because there are quite some sensors that are checking. Look at. Listening to me. So I want to be able to basically interface microphone, earpiece with ADC, and then PWM maybe, or I don't know if there's an internal DAC. What device will we use for that? Let me check. Oh, I must be. Yeah, it's really small. I need to find. Oh, I did taxes on Monday and have many invoices and everything open here. This is doxing deluxe. I mean, I'm doxing myself all the time, but this is beyond what's good. Oh no, it's not in my history, file history. Where is it? Okay, wait. I need the data sheet of CH32 to 8 not data sheet, reference manual. Go find me. Yeah, excavator is the dream. Where is this? What is the? Here, reference manual. Here we go. Do we have a deck? I don't think we have a deck here. We probably can only do ADC. Wait, let me. Oh. This one has a DAC. DAC. This one doesn't. The 208 doesn't have a DAC. What? It doesn't have the DAC. ADC, ADTM, no DAC, the 208. PWM might cut it, but what's the quality of the DAC though? I can use the smaller, I mean I have also the the smaller versions of the chips. I think I have the 203, I have even dev boards of that. So we can use that chip as well. I probably don't need as many pins. CH572. Oh, Rohan. Why? What was bad about it? Because I have the CH570 here, a dev board, and it has hardware multiplication and division, integer hardware multiplication and division. It costs only 12 cents and 100 megahertz and a lot of memory and flash. So we could external, but not the SGTL. I have an external DAC that works with I2S. Wait, I can put on. But it's also quite noisy. I'm not sure if we can use also the internal. Here it is. Wait, which one is it? External DAC. This is the one. Oh, this is the. I have ton of external DACs that we could use, but I think I would switch. Oh really? Yeah. Okay, you use them. They are quite fast, aren't they? Hey Task. You catch a stream. Welcome to the stream. Welcome to the crew. Oh wait, no, there. I thought there is. We missed a part. Yeah, I will use the V200. Wait, that's the F. Oh, that's the wrong data sheet. So what was wrong with the 572? Yeah, I show like some parts from streams now in my videos, which is quite cool because sometimes like the interaction or the joy or whatever, I express it more if there are people who are listening. So people are seeing that I stream. .96 kilohertz, but I don't have it here. I just. Oh really? Oh, VF. All right. Okay. Reference. That's the V. Okay. Oh, that's V300. V200. V203 doesn't have DAC. Oh no! Look at that. They don't have a DAC. What? The 300 version has the DACs here. Wait, let's check. DAC. I want it simple. If we can get an internal DAC. Let's scroll back to the in the beginning, please. Let's move here. I need to interface this device, this recording device, with an MCU that has USB. Okay, let's check again. That's the F version, alright. F. Hey, Graustreif, wait. Did I miss when you arrived or did I greet you already? Microchip. Yeah, I might buy the part then, but because if I don't do M.2 version, I can just order the PCB and assemble it myself. Resistor network. Here we go, peeps. Just like this. I used that with Arduino in my first projects. Resistor networks. My VGA cards also works with resistor networks. And I can just plug them in. R2R resistor ladder, yeah. We can do that. Okay, rehydrating my body. F. Yes, I did that myself. You know what? You know what's the funny part? Let me switch to the camera. I not only soldered them myself, I also etched the PCB myself with toner transfer technique. You can probably watch the video when I'm etching stuff like that. I'm not sure if I showed how I etched the resistor ladders, but it's the part of Arduino synthesizer video. I think, I'm not sure. Wait, do I have another one? Oh yeah, look at that. But you can also do it on a perf board. Has a resistor. I was talking about MuseLabs CH. Oh, MuseLabs C. Okay. I don't know. Yeah. So wait, where is the CH7? I have the CH570 is quite a good replacement for these tiny things. We could actually make it way better, the modules, because the chip is not more expensive. It's more than twice as fast. It has multiplication, so we could improve on the cluster. Okay, this is DAC. We can do a resistor ladder. I don't care. Let's do. Let's just copy the design, USB design from this board more or less. Here we can just clone this board design to have the interface here. And the only thing that I'm worried about is, okay, we have I never tried actually programming it. Where is it? The official board of CH. Where is it? Oh, by the way, yeah, here is the one board that has the 203, and I have plenty of those as well here. So actually, that is a design. Oh yeah, there is a botch. Look at that. Do you see the botch wire in there? Nice. Yeah, that's plenty good. Oh. Microcassette, yes. Izutsumi. What? It sounds Japanese. Yeah, I can't afford. I have Olympus because I can't afford the Sony collectibles. It's a bit botch. Yeah. For I don't know. I just did it for the show. Good application for risk carry. All right. So interfacing that. I need to basically, we can open it again. We disassembled it once and it was like, yeah, it still works. The buttons are a little bit, because they're very sensitive. The buttons are, but it was a headache because they're like sensors here. So you need actually keep, we can like remove the cover here, the metal cover, but we need to keep, stop it. Here, the metal cover, but we need to... Okay. Yeah, this is, I got it for 50 bucks. This is really, this was a catch. It is a little bit bent and stuff like that. He was like, glue from this thing here was oozing out and preventing it from opening. Just remove the glue, but you can see, I think this is just glued on, like the Olympus, and we can strip it down to like without the case. I don't need the display though. I don't need the speaker and the microphone, and I won't be needing the battery. And this thing runs, and there's always like in standby, it always shows the stuff from a single AAA battery. So what I'm worried about, if we interface it, we probably need to have a level shifter, because then I mean the buttons, they probably are just pull down, I hope. So we could do that without level shifting. ADC, we just lose some, I think like we lose like 2 bits, 1.5 bits in precision. And DAC, we can basically, yeah, we just use the lower power. But then we also need like 1.5 pancake motor. Okay, let me check. 10 Sony. Where are the buttons on a resistor ladder? What? Oh, I see that. But it's like a regular cassette, like the normal size, not the micro cassettes here. What I like about this device, it has 2 heads, one for forward and one for backwards. So we don't need to flip the cassette, and we could actually, maybe if we hack it, we can use like record that side and that side at once, or read it out at once or whatever, because this usually is mono, but then we could probably get more data or audio or whatever out of that, stereo or not. So the issue is, I need to find out if there is like a step-up converter. I probably not. It's probably designed for running on 1.5 volts, which is quite odd because drum memory. Yeah, it's not drum actually. There is no drum. But we might want to play around using QAM modulation and stuff like that. We might try implementing, or you can try implementing whatever modem compression, because this is like the audio quality is just like phone from the 90s. So probably 56K modem, whatever, encoding, audio encoding could be possible to store on there, like data and stuff like that. Some sand on here. Yeah, so I would suggest we can check. I will probably stick, since we don't get any DACs on. It seems on this board from the chips here. Only the V3 version have DACs. We can do a resistor ladder instead. That will be alright. Any speed variation? Speed variations? What one thing you will consider is storing data on one of those as Flutter. Yeah, that's alright. So we can talk about that. You don't get like a constant playback speed, and then you get like frequency shifts or whatever. And we can talk about that. I mean, we can use FFT or whatever, but usually I would say, if this is like, let's draw something. So we have, this is a frequency table basically, and we can pick like a, we can take like one frequency, like 400 Hertz or something, as basically a square wave. Wait, so, or in frequency we can basically use that as a clock, and then if there is a variation in speed, we will basically see a frequency shift like that, or this could be 1 kilohertz or something, just as a clock for the bits that we store or whatever. And then C64. Oh, okay. Yeah, I know. That's what we are going for. Anyways, so if we have like our QAM, how do you pronounce it? Is it like that? Or nay? Oh, wait, without you. Like that. You have frequency and phase. Here. That's the phase, I think. Phase. What's the P? I use phase and then frequency or something. Nee, what is that? Phase and amplitude. No. Was it phase amplitude? Yeah, whatever. You can basically use these points as like increase that, spend way more, store way more bits in that space. And basically what this will look like, we have then like whatever data that is stored here, and then if there is like a variation in speed, what will happen, we will have linearly a scale on here. So it won't be like shift, it will be a scale, but we can take our frequency here as the baseline, and scale everything like every other frequency in that window that we analyze, because we have like in frequency conversion, whatever, we can take that window and basically relative to our clock, we can just decode that. So I don't see it as a problem, but it will be enjoyable to test that, and I can't wait to interface this device. So I probably will assemble it myself to get it as fast as possible, get just some boards quickly, make a basic USB device, and then we can attach some wires, disassemble it, attach some wires, and then try everything. But what I would do now is I will disassemble it, and then we can maybe Maybe I should. I didn't record it. Damn it. I hope I can assemble it again, because I need for the video I need to assemble it again. So what we should do, we should disassemble it again and see if there is an internal step-up converter to 3.3 volts. That would be amazing. If not, then we need like some circuits or LDO footprint that I need to order then to basically get the one. Hey Quindor. To get like the 1.5 volts, and maybe if we can check the ICs, maybe we can run it even faster with a higher voltage or something. That might be interesting, with 2 volts or something, and then get more performance out of it, or break it entirely. So let's disassemble it, and then we will measure what do we need to consider there to have to interface it basically with some wires. Let's do that. So all disassemble it, and then we will. Oh, my back. Oh, I carried half a ton. No, it was like 200 kilograms of dirt around like 2 meters altitude, 10 meters altitude. Where are my screwdrivers? Wait, where? Oh, really? No, okay, here we go. Oh, shit. Oh, maybe I will... Okay, here, let's take a look at this nice thing. Okay, we can... Oh, nah, let's put in the battery. This is plus. Wait, here is plus, like that. Let's rewind. Oh, the cassette isn't inside. Let's put it in. Here we go. And then play. Do we have anything on there? No. Okay, let's record. Hello, Internet. Hello, dudes and dudesks. Okay, stop. Rewind. Oops. Ah, no, wrong. Ah. This is the wrong direction. I think this was the right direction, huh? I don't know. Where did we record it? We just do it again. Oh, 14? Okay. Really? Here we go. Okay. Yeah, the quality is terrible. Okay. That's really cool. We can maybe I can maybe use this footage already. Earpiece, micro. Oh, what? Nice. Oh, we can put like this is speed is 1.2. We can do higher speed though. It has internally. Then what is VCVA? What is that? Does anyone know what? And then reverse on off and remote. Oh, there is a remote. What? Maybe we can interface it over remote. Main and hold remote. That's cool. Compressor. Okay, so maybe we don't need like to solder anything. but I'm not sure if we will the remote has everything. I don't know. I don't have the. Okay. Extra silence. Ah. Just control playback, fast rewarding and rewinding. Okay. But what else do we want? Playback. It's probably like a resistor, whatever. Ah, right. Okay. Yeah, let's turn it off. The variable voice control actuator. Reverse on, off, off. Ah, all right. Okay. Yeah, we don't need that. Oh, there's also volume. Nope. Oops. I pressed it by accident. Okay. So let's take it apart. Let's take it apart and look inside. One battery. I hoped it was like two. Okay, let's open. This screwdriver is completely dirty. Do we have a different screwdriver? Yeah, here's one. That's even smaller. Small. Can't remember. It was a pain to put it together again. Oh yeah, there's one trick that I want to do, because I know that the buttons fall out. I will just use some tape to fixate the buttons here like that, so they won't go away. Hope. Here we go. Buttons stay there. Yeah. Okay. Buttons stay there because they will fall out. If I make a video on that device, it will be probably quite popular afterward. Oh wait, there's a different length. Where's the short one coming from? Was the short one this side? Oh no. Oh yeah, I think the short one is on the top. The long ones are from the back. Uh-oh. Can someone rewind? Can't get this out. Ah, here we go. Oh, that's a long one. Where's the short one coming from? We have a short screw. Short bolt here. Button side. Okay. Okay, I think this... Okay. So it's from the left side of the I think we had like... Oh yeah, here we go. Okay, so this part we can probably delaminate if we like, but there is like, oh yeah, there's this is one piece, everything is here one piece. We can probably not change that. I will also glue on the sliders because the slider switches will fall out as well. And we need to take care of that they stay in the position where we focus. So we use that, and there is another slider button. Okay, to remove that part. I hope it still works somehow. Okay, we have here short one. It's from the bottom. Maybe I should put them in the order. Wait, this bottom short. This was long screw. Short screw. Long. Already forgot. I don't know. Okay, I'm recording. I can just rewatch. But here I also no, this is long one. Okay, we had it. We had it taking it apart already. I know it's everything. Like the whole PCB is a big flat flags. Come on, why is the focus so annoying today? Also short screw. Yeah, this is painful to take apart because yeah, we need to slide it out here. Here the internals. So I think this is interface. This is the motor. Do I have a fly in here? The speaker is terrible, so probably that's one of the issues. This looks like it could be taken apart. I'm not sure about that. Yeah, flat flags nightmare, because if I want like to take it apart, I need like to, I don't know, unsolder stuff or something. Like this flat flags needs to be desoldered or whatever. But this still should be working now, like without the cover. Yeah, I moved the screws away. So let's. Oh, there is a fly in here. Hate flies. Oh, that's so cute. Pop, 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 pop. And yeah, we have the buttons here. This is playback. Which was which was playback? That's stop, play here. Oh, the head is flipping. So that's on the lever. We can either do only one or two, not both. Hey Lucas, that's a recording device from the 80s or 90s, I believe. Right. Yeah, we can reverse, I think. Yeah, no, we won't reverse it. Play, and the direction, I think we can play long or something to flip yeah, you saw it's flipping the direction. So long press flips the direction. Oh, that's tough to control. But this is basically. All right. All right, okay, stop it. So one thing to interface, we can just attach tiny wires here. But oh, that looks like it's ground, and this looks like it's ground because there is like this ground plane. Can you see that? I will just get closer. Here, you can see this side and this side. So let's measure what's happening there. And see if we can. Also, we have here, oh, look at that. We might be able to measure, to get like solder to the points of these plugs here. You will get, yeah, we want like to store data on that. That's the goal. Let's just store data. Probably I won't take it further apart, except maybe of taking off this cover, but then I need... Oh, wait. There is a screw. Oh. Let me take that apart. Very tiny screw. This is the shortest one, is from this cover. Maybe I can take that off without, if it's not glued. Oh. Yeah, it's glued on, but not as badly as I thought. Oh, the frame also removes. Oof. That's tough. I don't really like to remove the frame, but it looks like no, this is completely connected to the frame. But I can probably remove the cover. So and it's just only held by these tabs here. So I'm touching the tape. That's not smart. What was that? Something fell out. What fell out? Something. Here we go. Mechanic's still working. Yeah, we had problems last time. Something fell out. Oh, that's the glass. The glass fell out. Okay. That was that. I can remove that gunk here. We have some double-sided tape for that, so that can be still reassembled, people. Don't worry about that. Okay, I will take care of that later, but it probably still plays. Yeah, still running. The most important stuff, what we noticed last time taking it apart, there are quite some important sensors here. Let me stop it. Here there are some important sensors down there. Do you see that in the corner here? Here there are sensors that take like care of if it's closed or whatever. So we're stripping it quite down, but I don't want to take it further apart because this is one part, also like the display. Hit mouse recorder. Yeah. There are plenty of ideas that what we could do it with. Let's just start with trying to interface it and then move on from that. So that's cool. I was able to take it apart. Now we should measure the interface here. The only thing is I need 1.5 volts in here. The remote. Okay, let's check the voltages now. We could also just solder something on. This is not PCB design today. Oh, this fly is killing me! Ah! Where is it? Stupid fly. I hate flies. They are gross. Alright. Okay, let's measure voltages. So this should be, this looks like ground though, or I don't know if it's ground or not, but I hope it's pull down. If it's pull down, then we can if it's a pull down. Oh yeah, wait. Huh? What's going on? Is it flipped? What? This is oh, this might be VCC. 1.3. No. Huh? This is VCC? Huh? What? Is it inverted? Wait, let me... how do we check that? It shows -3. So it's probably pulling up then. So what is this, the ground then? Yeah, the manufacturing is amazing. Oh, this is VCC and this is ground or what? Then we have nothing here. Nothing here. Huh? This is like two different. In the center we have like some stuff, and here that looks like it's. We need to maybe take a look at this board here, but I can't. Can I take it out somehow? It will be hard to remove it from the frame though. This is tough. Oh, focus you. Ah. There's one screw. This is... Oh, really? Remote control has... Okay, let's measure the voltages for the remote control. Maybe we can just interface. This was the remote control. Yeah, there is... Wait, what happens if we short this? Oh, there is also this belongs also to the flat flags. Okay, here we got like this is VCC and ground, and this is ground and ground. No, no, this is like I don't know what this magic smoke. Should I just short it with VCC and with ground? Is the resistor ladder? Is it doing stuff? Resistor divider. Okay. Okay, so we should be fine by giving it like VCC or ground then. Okay, let's try that. Nothing happens. TRS? Yeah. But I don't see... Oh wait, I can't do... Wait, where's the... Okay, you know what? Let's move the battery and measure some resistance. Okay, this is VCC and ground probably. Oh, 1 mega ohm. This is 1 mega ohm. This should be like not 3 mega ohms. 3 mega ohms. 1K plus. Divider. What voltage does it expect, do you think? Yeah, I could use a pot, but I'm wondering if this here and this here is same. So we could basically measure the resistances of this one. Okay, let me check if we can measure if there is like resistance. between that one and some of those pins here. Oh, that doesn't work. What's going on? Strange. Okay, 0 ohms. $15 mega ohms. It's not connected here. Oh, that's 40K. Wait. 70K. This is 3 million. 4 million. Does the voltage change? Yeah, let me. We could plug it in and measure voltage somewhere. Yeah, we can press a button, but then we need to find out what is what here. So there is. Oh, I didn't measure the resistance between. Let me remove the battery again and measure the resistance between the terminals here on the buttons. Then we can find out. It's probably a resistor. It's strange. I don't see, like, there is no passive on the flat flags whatsoever. Okay, this isn't flat flags. I don't see passives on the bottom. It's really odd. Oh, the switches can be also interfaced. Like look at that. We can interface the switches if we want. That looks odd here. This part. I think it's good. All right. Is this the battery? Yeah, if there is no resistance, then there is no divider. Okay, I'm stopping recording because I don't want like a ton of footage that I can't do anything about it. Oh yeah, let's measure the resistance. Wait. Oh, you know what? I have new probes from Temu. Now, AliExpress or Temu? I think it was Temu. Way better probes than the ones that I got here because they are so pointy. I already stabbed myself. They are like needles. So I'm sure that I make contact properly because if there's like a coating or whatever, could be because we have an aluminum case. Wait a second. Oh. No, wait, this is here. Yeah, we have an aluminum case. Oh, but there is, you can see that. There is a protective sticker. Plastic lining inside. So actually they took care of that. Okay, let's use the Temu probes here. They're probably like 10 ohms internal resistance. Okay, let's try. Oh. Yeah, they're premium. Okay, 2 meg, 5 meg, 3 mega ohms. 2 mega ohms. Now try, because this one probably was. Oh wait, we have the terminals plus and minus here. So let's make sure continuity test. That work? Okay. Let's continuity test because I measured plus here. Maybe we can record that. Okay, so let's make sure this is actually plus. No, it's not. Was this minus? It's not either. What? What? What is this sorcery? Nothing is plus and minus here. Heh? I have no continuity. Okay, let's measure ohms then. Okay, I think this should be like low resistance. Okay, 5 kilo ohms. That's why we have a resistance. Yeah, there is 6 kilo ohms. Huh? 3 mega ohms. Huh? I should solder some probes and then measure it. But I would like to see what remote control, if we can remote control it with yeah. Oh wait. I wanted to test which one is which. If this was right, I think this was. Yeah, 300 kilo ohms. What? This is so strange. I'm not sure if I can trust those readings here. So strange. Okay, let's measure the voltages again. Okay, this was ground, I believe, and this was VCC. 1.32 volts. This was basically nothing. Millivolts. Yeah, this is sort of floating. Yeah, so we can put a resistor ladder in between here. Oh! Should we try to control it? I think we will attach wires to this here because I don't have the small tier C. I can check if I have one, but I don't think I have one. Wait a second. Wait a second. I think I have one. Where is it? Oh, my back hurts. My back hurts today. Yeah, I hurt myself today. How does the song go? Where is it? I will try the remote control for my camera because I have one for that. Oh, huh? I'm searching it, but it's in the camera. Here we go. Peeps. So I have a remote control for my camera, which has plenty of buttons. This is probably too many terminals. I will just alright, I don't know if that hurts. Nope. Nope. Nope, 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 nope. That doesn't work. Okay. I don't want to take my remote apart. I don't have another small TRS that I could sacrifice. On that. Yeah, let's solder on some wires. Can do this one here. Should we go over here? Now it's some hacking stream, not PCB design, but I really want to see if we can. This is a minimal invasive interfacing. Might be possible. Oh, what is this? Okay, here. Barf cam. I will move it over. Sorry. I don't like to touch on your face, but I need, otherwise you will complain about everything is entangled here. Okay, here we go. Opa. You can watch me from over here. I will just get some. I will use. Look at that. This is still my soldering iron with the wire wrapped around. I could use though. Yeah, I'll use it now. Yeah, let's remove the wire. We're done with that. Oh, is it unplugged? Yeah, it's unplugged. Bitluni unplugged. Maybe I can remove now. Settings. Alright. We don't need that anymore. They don't need that anymore. You know what? I fixed one. No. I don't know what you mean, but this is my makeshift one. Here we go. Whoop. Okay. Oh, look at that! This is my wires that were connected to the cluster board. Don't need that anymore. I will do new ones. Where's the magnet wire? Oh, I think I will use. Is it too stiff? No, I don't think it's too stiff. Maybe I could use like, yeah, this was more flexible. I don't want like to break anything, so using less stiff ones. Like get the knife. I don't want like to melt it off. Yeah, a very narrow space soldering. I will just exhaust fan. Don't look at this blue solder here. I have a good filter. What? Oh, is it heating? Okay, what? Yeah, it wasn't standby. Come on. I need a block off to get this insulation off. I need to block off solder. Ah, wow. I should maybe use like the other wires here, not this magnet wire. You what? Sorry, I didn't get it. I hope I don't break it by touching that there. Okay, here we go. Whoop. Next one. Oh, need to stay underneath that. Okay, I turn up the temperature to get it melting off the insulation, because that is dreadful. Okay. Okay, that's the next wire. I will put, I will connect it to a header so we can breadboard that. Here. Bring it to one length, then let's pre-tin it. Where's my exhaust here? Okay, this is tint. pressed the button on accident, by accident. It's still heating up. I think it's cooled down. Stupid. Bye bye. Come back next time. Maybe we have already some PCBs. Why is this tipped cooled down? Okay. Insulation doesn't want to get off. Oh, okay, here. It's gone, it's gone, it's gone. Okay. Now I put it, helping hands. My helping hands are really gross. They're like 100 years old. Not very good anymore. Get it closer, the camera. I should solder just above this plastic speaker. Okay, so this is one side. No, wait. This is one side. This is like plus minus whatever. Hope I don't burn myself. Ah! I burned myself. Okay, tweezers. What's going on? The solder is gross. Somehow it's like, you know, maybe it's contaminated or whatever. With the insulation that we just removed. Or is that maybe on the solder iron tip might be. Huh? This whole thing is. I have a bridge between the pins. What? Okay, here we go. I remove the gross solder. I put some on my tip. Oh yeah. There we go. Oh. Yeah, probably not enough flux. I don't want like a lot of smoke today. All right. Okay, back to the chopper. Look at that, we have a nice board. Piku, piku, piku. Oh la la. There we go. Ah. E. Yeah. Ah. Here we go. Now, we should be able to put a knob over here that we can, and then we will add a push button where we can just activate the resistance or whatever, the division. Okay, this can be removed. Oh wait, I have a better thing than a knob. Yeah, by the way, I can get this here. Where is the center? Yeah, it's almost the center. More or less like that. But we have also a slider, so we can actually see the position, more or less. We can see the position here as well. But I have slider resistors but they won't probably fit on this tiny board. Okay, let me get a button. Where is the button? Joystick, no. Audio jack, pin, long resist, dry buzzer, heat, pogo, no. The buttons. Huh? Looking for the buttons. Context switch. Spring potentiometer. Oh, there are more putties in here. No, I want mini buttons. Where are the buttons? Buttons. Rubber button, SMD button, switch, and ooh, this one is cool. Contact switch, dip switch. Huh? Where are the push buttons? Fader. Oh yeah. Yeah, this is certainly not. It would be cool for finding out the resistance. Oh! Look at that! I have one that's soldered to... Where are my buttons? I have only SMD buttons here. Rubber and stop, use contact switch. Okay, let's do that then. Whatever. They have like, no, they don't have the pins that I need. Can we use the contact switch? No, too wide. God damn it. It can't be that. Oh wait, here are the buttons. I found a drawer with the buttons, people. The exploration can continue. Here's one with long pins. Look at that. That's a cute thing. We can take that and then put some jumpers in between and we are good. But I take you over to the desk. So, going back to the desk. So, how do we tap it? I'm thirsty. Do I have still booster? Yeah. Okay, so what I do, this is the tappy tap. Tappy tap. This is this one. This is this one. This is this one. This is... Oh wait. No, this is this one. The center. This center goes here. Then this one goes here. Oops. And then we need that here. Okay, so we can select okay, so now we can change basically the voltage division, whatever, and then press the button to connect it with the main thing here. I hope that works. Otherwise we see magic smoke. Oh, there is no cassette inside. That's why it didn't work before. Why didn't you tell me anything? Okay, here we go. Let's remove that. Let's go to the center. Nothing. 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 This is not how this thing works. We measure it. Ouch. Just poked me. Oh. Wait. Did I solder the wrong wires? And this, where is this one going? I should have used proper wires, like with colors. No, eh? Are the jumper wires stupid? Okay. What is D-Lock? What is that? What is that product? Oh, terminal. Ah, nice. Yeah. What did I do wrong? Wait, this was... Oh wait, the remote needs to be activated with this switch. Completely forgot about that one. That puts the remote, but why don't I measure any voltage anymore here? Did I destroy it? Huh? What? Why is the voltage gone? Did I destroy something? Maybe with my solder I destroyed it, but I don't think so. It doesn't look bad. It looks still good. Okay, let me test it again. Oh, there it is. We have a voltage. Okay. Oh! What did I do? It works! It does something. Can I stop it? It rewinds. I don't know what it does. Wait, we need to see what it does. Okay. Now it's recording. It's recording. Okay. It's recording. So let's stop it. No, we are forward. Oh, we need to keep it pressed. Forward. Oh, it's recording. Why is it recording? No, wait. I want to stop it. I can only forward and record. Why is it automatically recording? Huh? There is only record. Oh, wait. Oh, wait, it measures across those terminals. These two, we have 10k ohms. That's recording. Here. So that's 10k. Oh no. So rewind is basically okay. So maybe there is no resistors whatsoever. It's just a combination between which pins are okay. Let's do that. That's forward. Okay, so center pin is rewind. Recording is basically the outer pins. That's recording. Then what is this? Is probably play. No, nothing. I have only rewind and record. But where's the play? How do we play it? Nah, there must be more to it than that. So probably there are actually resistors that we need to put there. So the divider is inside of that, and this needs to have certain resistors. So we can actually use that. It did something again. We can put in like a different resistance between, yeah, or diodes. We can put different resistance between this pin and this pin. Okay, no, that would be strange because you always like rewind and test it. Okay, so it plays back. Why? Oh wait, that plays back, but what is the rewind again? This is record. No wait, this is record, this. And this is playing back. But what is rewind then? Huh? I have no clue. There was the hello internet again. Play and record. We need some rewind. Okay, let's stop it and check if we can find on Olympus remote. There must be some remote. Oh, the photo of what? Did you find one? Oh, what? You can just shift it? Ah, yeah, I didn't get it remote with the device, unfortunately. We could measure that. Okay, look, let's take a look at that. Record stop. Oh, wait, huh? $3K, $36K, $2K. I mean, they probably reuse some of the old tag. What is... Yeah, I know, but I guess they will just use some designers. What do we have here? Why is this ground? Switch, stop. What is this? I can't read. What is the device name? I don't even have the device name here. Wait. Maybe on the front panel. L400. Yeah, L400. That's probably not out. Oh. Wait, it's in stock. for 99. Oh, that's used. But it doesn't come with the remote. At least I don't see it there. I think we need might be similar, you don't know, but it doesn't show anything. Record, stop. Oh. Oh, this is just the internal battery here. The 1.5 volt battery. So it connects 1.5 volts for record to the center tab, or it connects ground to stop. Can't do both, it will short. Short the battery if you press both buttons at the same time. There's probably a diode somewhere here, otherwise okay. Why is it so zoomed? Oh, interesting. There is like forum posts. Probably our resistance is too low. What did we have? Okay, so let's try different resistor values instead. Sorry, no PCB today because I need some debugging. Okay, what do we have? I have some other resistors, faders, potentiometers. We have bigger values here. What is this? 10K? 2.2 million. How about that? Okay, 2.2 million. I need a screwdriver. So, do I have a flat screwdriver? No. Yeah, there's one. I think this is playing back. Yeah. Doesn't matter what resistance it is. It doesn't care. Wait. Oh, what did I do? No. This. Huh? Yeah. Was wrong. Okay. The resistant needs to be like below certain value. How about that? Is there anything happening? Nothing happening here. So how about we move this by 1? Resistance between this one and this one. This is too high. Now it's recording. Recording, not recording. Nothing else. Huh? And this does nothing. Huh? I can only find 2 functions here. Record and playback. Huh? What did it do? Any ideas? You think there's like a diode or something? No. Okay, we have 3 wires. Or did I miss a 4th one? No, there are only 3 terminals. Let's draw it. Okay, so we have 1, 2, oops, 3. 3, and we have 1, 2, 3. We tried. Okay, this is nothing. We tried all the few permutations that we have. There isn't. This is not a permutation. This is not a permutation. It's not a permutation. What we could use is maybe a diode in one direction and the other. We can try that. But this would be strange. Who does that? Okay, let's try a diode. So we get, yeah, whatever. We'll try a diode. This direction does nothing. Then this direction does nothing. That's recording again. And this does nothing. And this is forward. I can only find two positions. Diode does nothing. Any other ideas, people? The voltage divider did nothing. Oh wait, we can maybe no. Maybe a lower value. And divide that one. I have 680 ohms here. Wheatstone bridge. What is? It's a tree only. I don't see a fourth contact. It should be soldered through the PCB, but there is only three terminals. What is the Wheatstone bridge? What do we do with that? I try to higher a resistance. Now let's try a lower resistance. I will switch in a second. Sorry. I don't see there will be any difference. That's recording. Any resistance records there. There is. Damn it. It's wondering that like between the other two pins there is no function whatsoever. Maybe we should try testing those buttons again. Or I disassemble it and we see how the PCB is made there. This is hard. How do I get in there? PCB, I don't know how to, if I would disassemble that, that's quite hard. It looks like here might be the main PCBs. No wait, here's the battery. It goes to this PCB. There is the PCB. This is the flat flags. But it looks like only to... No, that's the flat flex here. Speed controller. Okay, what do I see there? That's just speed controller of a cassette thingy. Okay, I just tested shorting the buttons and then we... Oh, this is rewind. This is playback. This is stop. Okay, that might be easier to to decode. Like the buttons might be easier to decode than the TRS remote control. So I got rewind there. Strange. I don't want to spend $100 on another device just to get the remote control. Although it would be nice to have like a second device. Should we try to interface those chips? But I don't have a lot of time. I mean, I have another 15 minutes or so. We could at least decode that. Sorry that there is no PCB design today. I really need to find out how that works, and then the issue is how do we... what's happening here? Is the resistor measured, or do we just connect? We could test it. You know what? Also, the switch. I'm wondering, okay, in this position, the switch does nothing. There is like no line going in. So in this position the buttons are active. Okay, so there is basically no... the remote might work always. Let's try if the remote works right now. No, the main IC just turns... Oh! Guitar, thank you for the follow. So let's figure. This is so bad. I really wanted to have that here working, but we can figure out what's happening here. Okay, so I think this was plus, this was minus or something. Yeah, 1.35 between those two. And there are these one. Rewind, no rewind, just play and record. We have that already. Yeah, we might want to interface this one here. Oh. We have 4 buttons, and there are 4. We have 4 buttons, and there are 4 functions. So, what does that one do? Wait, we can check it here on this thing. Okay, so, oh, the stop button. What does this? How does that work? Wait, let's try record. That might be stop. That's play. That's play. That's stop. That's rewinding. Can we? Recording is a different polarity. This is recording. Yeah. Okay, I figured it out how the buttons work there. So here we go. Boop. Okay, here we go. We have the flat flags. Can we get something? Yeah, that's good. So let's focus at that. We have the flat flags like that. That's a terrible flat flags. And then we have 6 pins. 1, 2, 3, 4, 5, 6. Okay, so let me do that. So this and this is stop. Is it stop or play? Forgot. No, this should be stop. Yeah, I think this was stop. Yeah, that's stop. That's play. Okay, this is stop. Stop. This is play. Play. And this is let's say rev, rewind, and this is record. Interestingly, record has like a reversed polarity, and don't know if we need like to actually switch those. I mean like, or we just use the voltage there. This is high side. This is low side. We could do this with MOSFETs. So this is, I think, like that. Yeah. So this is plus, and this is minus, and I think this has an internal pull-up. Yeah, and this is an internal pull-up. So what happens? Battery voltage, yeah. So that's basically 1.5 voltage, 1.5, and then we need like to pull up these three to get those functionalities, and we need to pull down this one to get record. I'm wondering if we can pull it up to, we would need like to pull it up to 1.3 if they are floating. If we have like 3.3 volts, let's assume we connect, we have a circuit that works like that. Maybe we do some circuitry. We figured that part out now. Yeah, we can, but I really don't want to. How do we start with a new? Yeah, let's start a new project. And docs my files here. All right, let me say. Oh yeah, probably that's what I suspect, because it would be shorting then otherwise. Wait, let me check that. There is. It's confused. It shows 0 ohms, but I think it's not. I should probably not have the battery in connected. I don't know. It seems to be confused. It's probably 1 mega ohms. It's moving around. So I guess this is what's happening there. tape. Alright. Yeah, save the changes, whatever. Maybe I shouldn't have. Okay, so let's take it here. And do it like that. I would say we can either pull it down or whatever. So let's do the interface here. Pin. Now header terminal 6. How is it called? Header. Okay, let's go now. Basics. We have 6 pins. Or connectors or whatever. Connector. Ah, here we go. Con. Okay. 1 times 6. Okay, so. Oh, damn it. I forgot how that works. The project took that time, that long time. Okay, so we have the connector. Oh. X like that. Let's zoom in. Then what we can do that's easy. That is like NMOS MOSFET transistor channel MOSFET. Okay, so this is basically we can take 1.5 V. That's here. Maybe I should also measure the resistance between the plus terminal and the outer one. So I actually know maybe there is a resistor. Now it's 2 mega ohms. What? No. 2.7 mega ohms it says. What? Between the, that's just a pull-up. But how is it? Wait, what? Okay, ground can be maybe lower resistance then, because we use a pull-up. Oh yeah, that's 5.6K. That's 5.6K. That's like, oh, this is like really low power, eh? 5.6K would be enough to pull it down. So actually what we have, as this is internally, can maybe do the explanation here and type, what was it, 1 M or whatever, 1 MR ohm. How do I type ohm? And whatever. Like that. This is 5K. GND 5K. Maybe let's leave the ohms away. Oh yeah, thank you. It helps. right. All right. I probably will stream. No, I can't. Maybe I can on Friday, because I now need to take care of my visitor. Okay, so, and then we can finish the board, or I will finish the board, and then this is like, this is rack, and then we have pull up. I don't know what was the pull up again? Did we measure the pull up? I didn't measure the pull up. I should measure the pull up here. Shouldn't be as, no, can't measure it. Oh, there it is. It's far away. Come on. It can't. There is too much logic in between. Okay, this is like pull up, rack pull up. That's probably, I would say that's probably mega ohm-ish. Ah! Where's my ohms? Because that's not drawing any power whatsoever. So ish, and then we have floating. What was our? Yeah, that's stop and play and ref. Stop. Oops. Yeah, I'm not so invested in that I would do that. Stop. Ref. No, play and ref. What was it? Yeah. Play and all right. Is this like draw wires, draw buses? No, there's no lines. Highlight nets, net labels. There's nothing. There's no like pointless wire. Ah, this fly. All right, so here we go. We can do NMOS. So should we need to wire it like that. That's the source. That's I hope this is the right way around. Oops. shit. How do I do that? Here. And then we need pull downs. Is that how that would work? This is the safe way of doing it. Otherwise we could just use resistor ladders and use whatever. No, we can't use resistor ladders because then we have always like current flowing. Okay, so we need resistor ladder. No, resistor, pull down resistors. I shouldn't cramp it there. It's like very narrow everything. Oh, also this one. Foo. Wait, let's drag it over. Resistance, then I hope, wait, when I do that, does it jump this? No, it connects it. That's why. Okay, let's do it like that. That should work. No, this one is further away somehow. Here. Oh. Yeah. Okay. This is ground. Right here. Okay, ground. Hey, Kicad. Oh wait, I missed that. It was a long time ago. Welcome to the chat room? Did I reconnect? Damn it, how do I do it? That looks shitty, and then I have a wire in this, just in the center of that. Okay, let's move it apart. Ugh, I hate it. Okay, let's move it apart. Let's drag it apart. Yikes. Let's drag this part back. Let's move. I don't want to move the wires. I think this will work. Okay. It's not properly spaced. I can't tell. Wait, this is D. This is S. Wait, no. I don't know. I don't care anymore. This is how it looked like. Alright, and then we have the wiring. We can do labels here. What is it? Stop. I can do a label play. Is it play? Label I might be wrong. I should at least test the circuit before I. Huh? What did I do? Why can't I? I pressed something now. It. Oh. Okay. Now I should test that before I do anything, and I should also try to power that. I don't have a voltage regulator, 1.5 volts. I might have somewhere one. Wait, let me check, because I have plenty of regulators. I have 2.5 volts here. I have an LM317 which could do the job. Just need to find the values. I will check if I have a actual 1.5 regulator, then we could put it on there. But this is how it looks like. One explanation before I end the stream, sorry. Mates. So I always check the direction of the body diode. So basically this is plus, this is minus. Source is, in MOSFET, source is minus. So here we go. The power doesn't flow in this direction through the diode because this is blocked. So blocked. This is like how you can memorize that. But it will flow as soon as here is a voltage that's higher than or similar to what we have in the drain. Then it will flow this direction, and then we have, yeah, this is needed for whenever our device is not powered on, then everything will be shut down. Otherwise it will do whatever, random stuff. We don't want it to do random stuff when we boot or whatever. So this is the same way all these I can stop here. Stop. Okay, here. No, the buttons are shorting those as well. So I'm not supplying it with actual. There is like this 1 mega ohm resistor here. So we are not supplying it directly with 1.5 volts. We could try doing that. Like, might work. Then we could basically just put a. No, we can't do this with a voltage divider. I don't think so. I don't want like to connect this to ground and whatever. This will be alright. I mean, that's only 4 buttons that we control here. So these are working like that. These are floating, and the record button is internally pulled up. So we need to pull it down. Since this is then plus, this way around it is blocked, and when I enable it, it will flow here, and to there. So this is how it will work, the interface. I will test it, and then we can continue. I hope on Friday. Otherwise, I might see you with a PCB on next week. But I will certainly. I like to stream more now that I don't have a project to edit. This weekend I might have visitors on Saturday, so maybe Sunday. If it is not Friday, then it might be Sunday. All right. Oh yeah, the Shipu. Hello, by the way. I didn't see you. Yeah, thank you for joining the stream. I have a ground symbol on pin 2. Where is pin 2? Pin 2. Oh yeah, ground. Yeah, it's saying here ground symbol. ground, and it is like 5K, so that's not actually like real ground. There is a resistance, so it's basically, this is a weak pull-up, really weak, because it should last forever. GoFundMe excavator. What is the GoFundMe link here? Defa 0 a that's the GoFundMe for the excavator, and I will have fun in my excavations. Anyways, thank you very much for joining the stream. Not much PCB work happened here. Almost dead beef. Dead beef. All right. Yeah. I'm curious how that will work out. I will put a resistor ladder in here, then we can design a basic PCB, or I will do it and order it, and then we will play around with that next time. Okay, that will be cool. And so I see you next time. Bye bye. Oh, what is this? Raided. What? No, you're coming late. Wow. Thank you for the raid. Oh, you're just coming when I sign off. Oh no. Peeps, you missed all the fun. Look at that. Here we interfaced the mini cassette recorder. Best visions. Hello. It is like a micro cassette. Oh no! I just it started. Here. It's a mini cassette recorder. Oh, it's confused because I touched the white. It's very sensitive. Yeah, and we want to interface it with a microcontroller. Perfect timing then. Interface it with a microcontroller and maybe store data on that. 4 of us raided to Platinenmacher, then we started raiding you, so if you raid us somewhere else, they get double raided. Platinenmacher? Okay, let's raid Platinenmacher then. Double raided. Oh wait, somewhere else Platinenmacher is done? Yeah, okay. So I will end the stream for the YouTubers. Thank you for watching, and then we will rate the Twitch. Thank you. Bye 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 YouTubes.